up next we have another data sufficiency question. If m and n are non-zero integers, is m to the power of n larger than n to the power of n? Statement 1. N is the absolute value of m. Statement 2. M is smaller than n. Take a second to pause the video, try to solve it, and then we do it together. Okay, let's start with statement 1. So the first thing to notice for statement 1 is n can only be positive. So n always has to be bigger than 0 because it's the absolute value of m. And m can be either positive or negative, -2, -3, or +4, or possible values just not 0. So let's differentiate the different cases. Let's say m is positive. So if m is bigger than 0, then effectively what we have is that m is the same as n, and so we know that m to the n is the same as n. Oh, that should be the same as n to the power of n. If m is smaller than 0, we have to differentiate, right? Because if you take something to the power, it's important whether it's an odd number or an even number. So if we take -2 to the power of 2, it will be 4. If we take -2 to the power of 3, it will be -8, it will be negative. So let's first say that m is negative and it's odd. In that case, the left-hand side, minus to the power of something odd, will be negative. So the left-hand side, let's say left-hand side, right-hand side, the left-hand side will be negative. The right-hand side will be n, which is positive, to the power of something positive. This will be positive. So in that case, we can be sure that m to the n will be smaller than n to the n. Now, if m is negative and even, then basically what we get, the left hand side will be positive because it's, for example, -2 to the power of 2. So this will be positive. The right hand side will be positive as well. But what we get is that m to the n therefore must be the same as n to the n. So these are all the different cases, and there's no case where m to the n is actually bigger than n to the n. So statement 1 is enough because we know that they can either be the same or m to the n is smaller. Okay, let's look at statement 2. M smaller than n. So here I would just try a table. Let's say we've got a table with our 4 different columns for m, n, m to the n, and n to the n. We try negative value here, 3, let's say 2 there, so m to the n would be 9 and n to the n would be 4. And then we can try another one where m is -1, n is 2, so m is still smaller. M to the n would be 1 and n to the n would be 4. And so these two conflict each other. So statement 2 is not sufficient, just 1. Yeah, A.